Welcome to CW 1.3. Today we're going to talk about how to use parabolas and the vertex formula in the context of a real-life situation. So take a look at this question here. The marketing department at Texas Instruments has found that when certain calculators are sold at a price of P dollars per unit, so we see math already, let's highlight that, P dollars per unit, the number X of calculators sold is given by the demand equation. X is equal to 21,000 minus 150p. Okay, so that's just some general information. Let's do letter A. Find a model. So if you ever see find a model, that means find an equation that expresses the revenue as a function of the price. So to do A, this takes a little bit of common sense. We're going to write A, revenue is equal to, look at the variables they gave us. They said we're selling X calculators. So X is the number of calculators sold. And then each calculator is P dollars. So to calculate how much money you make, you simply write P times X, because that would be the number of calculators, X, multiplied by the price of each calculator. That should generate how much revenue you get. But notice how it says as a function of P right here. That means everything has to be in terms of P. So we come back to our equation. So this P is okay, but X, notice how they gave you this fact. X is 21,000 minus 150p. So you simply plug it in. And now that the X is gone, we can simplify. Revenue is equal to 21,000p minus 150p squared. So revenue is negative 150p squared plus 21,000p. And there's the answer for letter A. For B, what is the domain? We're actually not really going to cover that in this unit, so we can cross that out. We can actually also cross out G. We're not going to do this part. Letter C. What unit price should be used to maximize revenue? So this is a really important keyword, maximize. If you ever see this word, maximize or even minimize, that's going to be a huge indicator that we need the vertex. And from our last class, we learned that vertex, the formula is negative b over 2a, and that tells you the x value of the vertex. So for this one, let's do that. Let's find the x value of the vertex. And I'm going to put that in quotes. So x value, because if you look at our equation here, notice how there is no x. I put it in quotes because that represents like the actual input of the equation. So let's plug it in. Negative b, that would be negative 21,000 divided by 2 times negative 150. This is your negative b over 2a. This becomes negative 21,000 over negative 300. We can reduce our negatives, cross out these zeros, and we can see that should reduce to 70. Now, it's important to understand is what you just found. This is the x value of the vertex. Now, in our equation here, P is your quote x value. R is your quote y value. So we just found the P value, which means 70 must be the price. So actually, we just found the answer because it says what unit price should maximize the revenue. That would be the x value of the vertex. I know right now it seems kind of abstract, but once we actually sketch the graph, this should hopefully make more sense. So for now, just copy this down and write down that is our answer. Now we go to D. If this price is charged, what is the max revenue? So simply plug in 70 equals P. So you can use your calculator, and I'll save you some time as well. Negative 150 times 70 squared plus 21,000 times 70. After you plug that in your calculator, you're going to get $735,000, which means if we sell our calculators at $70, that will maximize our revenue, and we'll get expected about $700,000. Okay, E, how many units are sold at this price? So there are a couple ways to do it. Some people like the formulaic way, that we write R is X times P. That's what we had right here at the beginning. We're looking for how many units are sold. So we're looking for X. So X should be the revenue divided by the price. And some people just think of that intuitively. So they'll just simply divide part D and part C right here. So again, use your calculator, 735,000. That's your total revenue. Divide by the price of each calculator, and that's 10,500 units or calculators sold. Okay, so that's a lot of just numbers and showing you how to calculate things. The graph, I'm going to show you how that kind of puts everything in more context. So the graph, if you were to use a calculator and actually graph the equation we found above, it would look something like this. Here's our x-axis, or the p value. The y-axis is your r value. And it would look something like this. It'll give us an upside down parabola, which makes sense because notice how this value here is negative, so that should be a negative parabola. And the vertex we can see is right here. There's our vertex. And the coordinate of that vertex we found to be 735,000. So in the question where it said what unit price would be used to maximize revenue, notice how this is the one that maximizes the revenue, the 70. And the 735,000, that's your max revenue itself. So the picture should hopefully help you make more sense of what we just did. So essentially, whenever you see the word maximize or minimize, you are looking for the information around the vertex. So that's all we did there. And of course, after this video, we'll have time to talk about it if you have more questions. So now we go to our second example, maximizing the area enclosed by a fence. So it says a farmer has 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? So you see this word most, maximize. Anytime you see that, you gotta think this is a vertex problem. So that's what I really want you guys to understand and train your brains. You ever see the word maximize, minimize, most, you're looking for the vertex. So questions like this, they aren't too bad as long as we just think through the information we're given. So we have 2,000 yards of fence. So if you imagine there's a rectangular field here, let's draw a rectangle. Let's call this L, let's call that W. If we have 2,000 yards of fence, that would mean the perimeter is 2,000, because the perimeter would be how much fence we put around the whole thing. And we also know the perimeter, if we add up all these variables here, that's simply 2L plus 2W. So we plug it in, this right there. 2,000 should equal 2L plus 2W. We can simplify, so divide everything by 2 or multiply by a half. So 1,000 is equal to L plus W. And now it says, what are the dimensions of the rectangle that enclose the most area? So I draw a line here. Let's really think about area. To calculate area, isn't that just length times width. And we're trying to maximize that. And look right here, we found that 1000 is L plus W. So let's just solve for one of those variables. I'll just solve for W. So W should equal 1000 minus L. What I'm going to do is grab this expression and plug it in for my W right there. So now I have A is equal to L times 1000 minus L. And now let's simplify. And look at this. Now we have a nice quadratic. And once you have your quadratic, we can find the vertex. So let's do negative b over 2a. That's negative 1000 over negative 2, which would be 500. Now remember, this gives you the quote x value, or the input. So look back at this equation right here. The input is L. So this is the length. Now look at the question. It says, what are the dimensions of the rectangle? So if 500 is the length, look back here, that would mean the width must be 500 as well. Okay, now we could do that, and that's pretty good. We also want to be more clear with our units. So we'll just say, we'll take this information, we'll go up here, write this in blue. The dimensions are 500 yards by 500 yards. Now notice how it asks for the dimensions. In the event it asks for the area, all we would do is simply multiply these two numbers, and then you get the max area. Okay, now I know those are challenging questions, so don't worry if you have questions, we'll talk about it. And we're also going to do the next questions right here together so we can get more practice.